So here I want to do some more examples regarding the first theorem in the previous video. Basically the last theorem we did from section 6.2. I want to do more examples applying that. And again, here we're assuming P is a point that is on the terminal side of some angle theta that's drawn in standard position. And here, as you'll see, P is not necessarily going to be on the unit circle. You know, it might be too far away or maybe too close even to the origin. However, with that theorem, remember, we can still calculate the trig functions at that theta. Okay, so here's our point P, which is 5, negative 12. And again, if either of the coordinates here is either greater than 1 or smaller than negative 1, then P is going to be too far away. That is, P is not going to be on the unit circle. It's going to be too far away from the origin. So in this case, right away, I could tell you P is not going to be on the unit circle. I mean, let's calculate the distance anyway, just for practice, if nothing else. So the distance between our point P, again, which is 5, negative 12, and the origin, again, the origin is 0, 0. So that distance is, we're going to have the square root of 5 minus 0 squared plus negative 12 minus 0 squared. So 5 squared plus negative 12 squared. That's going to equal to the square root of 25 plus 144, which is the square root of 169, and that turns out to be 13. So in other words, P is on the circle whose center is the origin, and the radius is the square root of 13. So again, we're going to let R be this distance, square root of 13. And now, which again is bigger than 1, well, it's not equal to 1, that's really what matters here, but it is bigger than 1. So now, sine, which we want to get, sine of theta, right? That's going to be, it's going to be y over r. Y, as we know, is the y coordinate of our P. So in this case, we're going to get negative 12 over the square root of 13. Now for secant, if you remember from that theorem, secant of theta is r divided by x. So in this case, we're going to get the square root of 13 over 5. So that's our sine, and that is our secant of theta. Okay, so here's another example. P again is on the terminal side of some angle theta drawn in standard position. We're going to find sine of theta here, cosine of theta here, and cosecant of theta. So again, we need the distance between P and the origin. So we need the distance between P and the origin. And let me just, wasn't wrong what I was going to write, but let me just write out the coordinates. So what is that distance? Well, that's the square root of 1 over 4 minus 0 squared plus 1 over 2 minus 0 squared. Okay, so that's what we get over here. Of course, let's simplify that. So we get the square root of 1 over 4 squared plus 1 over 2 squared. Okay, that's good. So now we have the square root of 1 over 16 plus 1 over 4. Okay, well, since we're adding, we want the denominators to be the same. So what I'm going to do is this. I'm going to rewrite the 1 over 16 we're keeping. 1 over 4, I can write that as 4 over 16. So we're going to end up with the square root of 5 over 16. And just to make it a little bit easier, we can write this as the square root of 5 divided by the square root of 16. It's basic laws of exponents. Now, the square root of 5, there's not much we can do with that. Square root of 16, 16 being 4 squared, we're just going to get 4. So this is what r is. So r is square root of 5 over 4. And I want to write p again down here just to make it easier. Okay, so let's determine sine of theta. So remember, for the sine of theta, that's again always y over r, which in this case is a half divided by radical 5 over 4. Now that's not, I mean, technically it's right, but that doesn't really look nice. But this is the same thing, remember, as 1 over 2 divided by radical 5 over 4. Okay, so what is this equal to? Well, this is going to equal to 1 over 2 times 4 over radical 5. So in other words, we're flipping the second fraction here. We're flipping it. And then we're multiplying. And so, of course, we're going to get 4 over 2 radical 5. Okay, now 4, of course, is 2 times 2. So just to make it a little bit easier, we have 2 times 2 over 2 radical 5. Okay, so the 2's are going to cancel, and we're just left with 2 over radical 5. Oh, that's good. Now let's get cosine of theta. Well, cosine of theta, that's x over r. So the calculation is going to be similar. X is 1 over 4. R, as before, is radical 5 over 4. And, of course, this is 1 over 4 divided by radical 5 over 4. And so from here, we're going to get 1 over 4 times 4 over radical 5. So when you multiply it, you get 4 over 4 radical 5. And, of course, the 4's here are going to cancel, so we're left with 1 over radical 5. And now finally, for cosecant of theta, that is r divided by y. Okay, now for r over y, I'm going to go through the calculation again, but what will happen is you'll see your answer is just going to be 5 over radical 2. And how do I know that? Well, y over r we got to be 2 over radical 5. R over y, what we're doing here is taking y over r and inverting it, taking its reciprocal. So in the end, we're going to end up just inverting this. But let me go through the calculation just for practice. So this is radical 5 over 4. Y is 1 over 2. Okay, so what do we get? We take this. We're dividing by 1 over 2. Okay? And what do we get? We have radical 5 over 4 times 2 over 1, right? So here we have radical 5 times 2 over 4, but we know 4 is 2 times 2, just like before. Oh, that's good, because now we get some cancellation. And so we're left with radical 5 over 2. So that's cosecant of theta.